Hey, fourth graders, Mr. Klingon here. So we're going to go over a few more division strategies today. I know yesterday Miss Herman went over, making drawings and using tally marks and making arrays or kind of an area pattern to solve division problems. And today we're going to look at how we could use both number lines and ratio tables to solve some problems. Okay, so um, the first problem we're going to try to solve, this is one that might look familiar from some of the independent work you were doing yesterday in your packet, is this one. So it says, during dinner at Camp Mosquito, 6 campers can sit at each table. How many tables are needed for 24 campers? Now, a smart thing to do is to first start by writing down what's the information that we have, okay? Because some word problems especially can be really long. So if you just write down the important information, that can make it clearer for you to understand, okay? So I know that there are 6 campers per table, and we have 24 campers, okay? So if I'm thinking about division, I want to take a big group of 24 campers and I want to split them into different tables in groups of 6, groups of 6, groups of 6. So that's a division situation, and that's kind of giving me this equation. 24 campers divided by 6 campers per table, and that's going to tell me T, how many tables do we need, okay? So I'm going to show you how to solve this in a couple different ways, okay? First up, we'll do a number line, okay? So I'm going to make a number line. I put arrows on both sides. That shows that it goes in both directions forever. It's an open number line, okay? So I'm going to start at 0, okay? And I'm going to count by 6s until I get to 24. And I'm going to see how many times do I have to do that. So let's do once. If I start at 0 and add 6, that gets me to 6. We're still not to 24 yet, so let's keep on going. Let's add another 6, okay? 6 adds 6 more, 2 6s, that would be 12. Let's add another 6. 12 adds 6 more. Maybe you can do this in your head. You're adding 6 1s to 2 1s. That gives me 8 1s. Okay, so I have 10 and 8 1s, which makes 18. Okay, add 6 more. We're still not to 24 yet. Okay, maybe this time you need to count on in your head or on your fingers. Okay, so we're at 18. I'm going to add 6 more. 19, 20, 21, 22, 23, 24. Okay, I added 6 more. Now we're at 24. So let's take a look. How many 6s did we have to add? 1, 2, 3, 4. Okay, so 24 divided by 6 equals 4. Okay, so T equals 4 tables. All right, now I'm going to show you how we could do this with a ratio table. Okay, so a ratio table, you can set it up and down or side to side. It doesn't really matter. Okay, so we're going to have 2 categories. We're going to have tables, because we're trying to figure out how many tables we need, and campers. Okay, so remember, there are 6 campers per table. So if I have 1 table, that's 6 campers. If I have 2 tables, that would be 12 campers. If I have 3 tables, that would be 18 campers. Okay, hopefully you're starting to notice a pattern here. Here, every time we're adding plus 1, plus 1. We're adding 1 more table. And every table we add 6 more campers. 6 more campers. Okay, some people might also notice a pattern from tables to campers. That's times 6. times 6 times 6. Okay? And then lastly, we get to 4 tables, and that is our 24 campers, right? That is how we found our answer. 24 campers, we need 4 tables. So again, 24 divided by 6 would equal 4. Okay, 4 tables, I should say. All right, that's our first one. Let's try another problem. Okay, I'm going to use both strategies again, number line and ratio table. Okay, so here's another one. This is problem 3 from our work problems yesterday. So it says tennis balls come 3 to a can. And here's a picture that shows that 3 tennis balls in each can. Coach Brammer has 27 tennis balls. How many cans does she have? So again, I'm going to start by writing down the important information. So there are 3 tennis balls per can, and we have 27 tennis balls. So again, I'm thinking about there's this big pile of 27 tennis balls, and they're going into a can 3 at a time. So my division problem would be 27 divided by 3, and that'll give me C. How many cans do we need to fit all those 27 tennis balls? So let's start with the number line again, okay? Making a nice open number line, all right? And now instead of counting by 6s, like we did with last problem, this time we're going to count by 3s. We're going to keep on going until we get to 27. So here's 0. Let's add 3, and that's 3. Add 3 more, 4, 5, 6. Add 3 more, 7, 8, 9. Add 3 more, 10, 11, 12. We got to keep on going until we get to 27. That's how many tennis balls are there. Add 3 more. 12 plus 3 is 15. Add 3 more. We're at 18. Add 3 more. We're at 21. Add 3 more. We're at 24. Add 3 more. And we're finally at 27. Okay, so let's count up. How many times did we have to add 3? Okay, how many cans was this? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so C equals 9 cans. We need 9 cans in order to fill up all those 27 tennis balls. Okay, let's do a ratio table this time. Now, before I showed you vertically how to do a ratio table up and down like that, especially since I have a kind of a long, skinny piece of space here, we'll do a side-to-side ratio table this time, okay? Okay, so the categories I'm going to be counting by cans here, and then down here, tennis balls, okay? All right, so 1 can, we saw in the picture and we read in the problem, will hold 3 tennis balls. 2 cans would hold 6. 3 cans would hold 9. 4 cans would hold 12. 5 cans would hold 15. Okay, hopefully you're starting to notice our pattern here. We're adding 1 can every single time. And then every time we add a can, we're adding 3 tennis balls. Okay, so another pattern is it's like we're doing times 3. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12, and so on and so on, okay? So let's keep going until we get to 27. 6 cans would hold 18. 7 cans would hold 21. 8 cans, adding 3 more, or doing times 3, that'd be 24. 9 cans times 3, or add 3 more, would be 27. So again, Here's our answer. We would need 9 cans to hold 27 tennis balls. So 27 divided by 3 would equal 9 cans. Okay? All right. Here's what I want you to do for your work today. Okay? In your packet, I want you to do the division models pages. Okay? So they look like this. It says page 1 of 2 and then page 2 of 2, division models. So there's ratio tables. Okay? There's some area models. There's some number lines. All right? So different ways that we've talked about on how to divide. Now, at the bottom of these pages, focus that. There we go. You'll see there 12 and 13. Okay, so you can think of these as pages 12 and 13 in your packet here. Okay. After you do those division models, okay, which say 12 and 13, then you can go on to Dreambox, and we're going to always do at least one activity. All right, excited to see what you are able to do. Good luck, everybody.